we are going to do sum and difference of two cubes. So what are they? So we've done difference of two squares, but now there are sum and difference of two cubes. There are two formulas. So let's look at the formula. They're a bit harder. That's why we don't teach you in year 10. We teach you in year 11 and year 12. So there's a difference of two cubes like this one and a sum of two cubes. So they are factorized like this. If it's a difference of two cubes, the first factor is a minus b, followed by a squared, ab, b squared. Now do not get confused with the perfect square formula. If I go a plus b squared, you get a squared plus 2ab plus b squared. It's different. See, that has a 2, that doesn't have a 2. So that's different. Not to get confused with these two. Now, if it's a plus, it's going to be plus c, but there's a minus c. But everything else is the same, right? They look very similar. So in both cases, you will see that there is a minus. There's a minus c and there's a minus c. So if it's a difference of two cubes, it starts with minus, everything's plus. If it's a plus sum of two cubes, then there's a minus sign in the second bracket. All right. Okay, so where do they get the formula? To find out where they get the formula is to expand the right side. So let's try expanding the right side. So if I expand it, hopefully I get difference of two cubes. So if I expand this, I get a cubed plus a squared b plus ab squared, right? Then you do minus b times a squared, which is negative ba squared, negative ab squared, and then minus b cubed. And hopefully you see the cancellation. So after expanding, you will see that the ba squared and the a squared b gets cancelled because they are opposite sign, and the ab squared and the negative ab squared gets cancelled. So the only thing that survived is the a cubed and the minus b cubed. So lots of cancellation. So with factorize, we get something much bigger. Okay, factorize. Any questions? And you can do the same thing with sum of two cubes by expanding. We can prove it. Try proving it, which is not hard. You just have to go through the arrows. Have a try. And hopefully you get a cubed plus b cubed at the end. Hopefully. All right, have a try. Expanding. So you go a times a squared, you get a cubed. A times that, you get negative a squared b. Times that plus a b cubed, b squared, right? And you keep doing. And then times these ones as well. All right, see what you get. So let's continue with that. So the bigger screen. Okay, so what do we have? You get ba squared plus minus ab squared, and then plus b cubed. And then you'll see that these two terms cancel, and the other two terms cancel too. So you're left with a cubed plus b cubed, as we expect. So the hard part is now trying to remember the formula and trying to apply the formula. Okay? So what we're going to do is, let's write the formula again so you get the practice. So the first one is a cubed plus b cubed. It starts off with a plus b, right? Bracket a squared minus, because there's a plus, so you remember to put the minus in the second bracket, ab plus b squared. And the difference of two cubes will be a minus b, but then you go a squared plus ab plus b squared. So we're going to use this formula for part A. So in part A, you have to write that as x cubed plus something cubed. What cubes become 64? So how do I find out what cube becomes 64? What you do is this. You can use the calculator. Maybe just try finding the cube root of 64. You should get the answer 4. So that's 4 cubed, isn't it? And once you know that's 4 cubed, you know you have to use the first formula to factorize. This one here. Again, look carefully at the structure. So if you're still not used to it, just write the formula on top and write the copy down the formula. So you can just transcribe what you see. So you just have to substitute. So using the formula, it becomes x plus 4 because the a and b are the x and 4, bracket, and then you go x squared minus x times 4 plus 4 squared. Get it? Right, just substitute into the formula. And if you simplify further, that will be x squared minus 4x plus 16. So you need to square the 4 and write 16. Alright, any question? So it's more complicated, but if you just use the formula, it's actually not too difficult. That's the end, yeah, the end. Yep. Alright, let's try another one. You got 8c cubed minus 1. Now remember, write the 8 as 2. C all cubed. Because when you cube the 2, you get 8, isn't it? Minus 1. And then you have to do the factorization. So you go 2c minus 1. Right? And then you have to go, be careful 2c, but put a bracket around it. You have to square the whole thing. Square 2c minus 2c times 1 plus 1 square. Like that. So that's the a square minus 2ab minus ab plus b square. So you end up getting 2c minus 1. Oh, sorry, I just meant, yeah, so it's a plus c, yeah. So if it's a minus c, there's a plus. Okay, and then you square the 2c, which is 4c squared plus 2c plus 1. Yeah. Any question? Right. Pretty straightforward, hopefully. And then we've got 2 more to go. And then we'll do some mixed factorization. And then you can start the work. All right. Good? Okay, let's, yep. Yeah. Why is it not 2c plus instead of minus? Oh, good question. Now, if you just look at the formula, yeah, we get this confusion. So that's B is the B, right? B. It's the B which is 1, not negative 1. So that minus is just used here and there. But when you look at it, you look at the 1 as a positive 1. And that minus just tells you to use this particular formula. So you can't, yeah, if you think of a minus 1, you could, then you have to write it like this. AC cubed plus negative 1 cubed. There will be sum of 2 cubes. So in that case, you go 2c plus negative 1, 4c squared, but then you have to go minus 2c times negative 1, which you will get plus anyway. So you use the sum of 2 cube formula. If you think of this, yeah. But you still get the same thing. You still get that one. But it's better off just recognize the minus there, and the b is actually positive, not to put another negative. Yep, all right, good question. All right, let's rub this off so it doesn't get distracted. Okay, we're now going to do 2 more. Now, what do I do for the next one? The next one's a bit different. The next one is 6 is not a perfect cube, isn't it? And so is 48. But if you factorize the 6 out first, you do get difference of 2 cubes because 8 is now a perfect cube. So you get 6 y cubed minus 2 cubed, and you then use the formula. Okay? Use formula. I need to get a formula sheet ready so you can all have it. Alright, formula sheet. Alright, okay, so hopefully you're now very familiar with the formula, so I could just go y minus 2 minus, then y squared, and then you have to be plus y times 2 plus 2 squared. Right, it's pretty easy. So y minus 2, y squared plus 2y plus 4 is your final answer. All got it? Try the next one. Next one's very similar. Take the 2 out first, and it should do it. Okay? Just put a bigger screen, and then okay. All right. Let's start the part D. So you take the 2 out first, which is r cubed plus a, and then it becomes sum of 2 cubes. Doesn't work properly. Okay, and then you can do 2r plus 2 and then r squared minus r times 2 plus 2 squared. Sometimes the pen doesn't work properly. Alright. And then you get 2r plus 2r squared minus 2r plus 4. Okay, any question? Done? That's the final answer. Now, did you copy it down? Say again. Good. Quickly, because I'm going to move on to the next page with the mixed factorization. Then you can start the work. All done? Okay, I'm going to ask you to copy it later. So I'm going to move on to the next page. Make sure you do what I wrote on the board. Nat, yes? Okay, now let's look at this. Now, obviously, when the question test says it's a difference or sum of two cubes, you know what formula to use. But in the test, they don't tell you what formula. You need to recognize which factorization technique you use. Let's categorize them. If it's a binomial, means two terms, bi means two, you always do the first thing as look for common factor and check whether it's a difference of two squares or sum of two cubes. And then use the formula accordingly. If it's a three terms trinomial, you always look for a common factor before you apply the quadratic factorization technique. And if there are more than three terms, you group in pairs, which is like four terms. So we categorize into three different types: two terms, three terms, four terms. And for all these types, the first thing you do is always look for a common factor, then do the factorization. All right, let's use this technique on these questions. Okay, part A, two terms. So what's the first step? Look for a common factor. Are there common factor? Yes, there is. X is common. And after you factorize, double check, is there a sum of two cubes or difference of two squares? None of the above. So you say it's finished. All right, let's do the next one. Two terms. Any common factor? No. Is the difference of two square? Yes. So let's do difference of two square minus 4 square. Like that. And then you go x minus 4, x plus 4. Good. Okay, how about the next one, C? Alright, is there any common factor? No. Is there sum of two cube? Yes. So you do sum of two cube formula. And then you go x plus 2, x squared minus 2x plus 4. So by now you should be able to do it very quickly without showing too much working. Alright, any questions? So we've done the first three questions, and then there's more, part D, so I'm going to go to the next column. Alright, trinomial, three terms. And then you check, is there common factor? No, no common factor. Is that quadratic? Yes. So you have to look for two numbers which multiply to get 21, add to get -4. And what would it be? Yes, 3 and -7, that works. So you just have to do x plus 3, x minus 7. Done. Question. Alright, good. Once we're done, we can do part E. Alright, are there common factors? This one they do. Y is common. And then, is a quadratic inside? No. Can we do anything more? No. See, different. This one's you can quadratic, but this one take the y out, it's no longer quadratic. So it's different. Okay. Alright, next one. Next one is this four terms. What do I do with four terms? Group, common factor and grouping method. Are there common factors? No. Could we group them? Yes. Let's group them. X is common, x squared plus 1. Second one, no common factor, just take the 1 out. They both have got x squared plus 1. So you take the x squared plus 1 out, x plus 1. Can we do it further? No, because there's no formula for sum of two squares, right? So there's a formula for this, there's a formula for that, there's a formula for this, but not a formula for sum. Not for sum. Okay, there's only three formulas. The difference of two cubes, sum of two cubes, difference of two squares, that's it. This one cannot be factorized. So you just leave it like that. Alright, any question? Now, I just realized there's some challenge question I would like to go through with you. Let's do some challenge question. We want to do all of it? Yep. Yeah, sure. So we are, yeah. X plus 3, x minus 7? Yep. Okay, good. All right. Now, the challenge question are not on the next page. It's actually on page 14. Don't know why I put it over there. Maybe it's the end of the topic. So if you go to page 14, there's some challenge question. But I didn't write the challenge. I forgot to do that. Let me write the word. They are a little bit challenging. And you will find some of these questions in your textbook. Let's explore this. Let's do the first one. What should I do first? What's the first step? Always the first step is? Yes, common factor. Are there any common factor? X. Take that out. And once you take the common factor out, it becomes a quadratic, which is something you could factorize. Okay, so go to page 14, please. Page 14, okay? And then after this, you can go factorize the quadratic. So it's -1, -7, right? That's it. Done. All right, see if you can do the next one. I think next one very similar. Have a try. But a little bit harder because I think you get non-monic quadratic. Non-monic. Have a try, see if you can work out. So the next one a little bit challenging. So okay, take our common factor, which is t squared. 6t squared minus t minus 2. PSF, so you get p is -12. Sum is -1. What would it be? -4 and 3, right? So be careful. You have to go like this. You have to go 6t over 6. And then you write -4 there, plus 3 there, and then you look out a common factor, which is the 2 and the 3. So you go, take the 2 out, which is 3t minus 2. Take the 3 out, which is 2t plus 1 over 6, because the 6 has to be cancelled. And then you see that this 2 cancel with the 6, which becomes 3. The 3 cancel with the 3. So your final answer will be t squared, 3t minus 2, 2t plus 1. So it can get challenging, especially the non-monic quadratic. They are a bit harder to factorize. Oh, the next one's even, all right. And then the next one, oh, okay. I may skip the next two first. I'm going to look at E first. And then I'm going to look at, oh, there's some horrible one. But anyway, we'll just do these two. And then look, let's focus on the E. Let's do E first. But if you try C, we will go through C. But let's try E first, because it's more familiar. All right, E is actually 4 to the power of square. And write m to the power of 4 as square of m. Right? So even though it looks like difference of 4 powers, it's actually difference of 2 cubes. Difference of 2 squares. But the key is to write the m to the power of 4 as m squared squared. Right? By index law. And then you can go 4 minus m squared, 4 plus m squared. But you always have to do the one extra step of checking. Can we do further? We can, because 4 is this is a difference of 2 square again. You have to do it further until you can't do it anymore. So 2 minus m, 2 plus m. However, the second bracket being sum of 2 squares has to be left as it is. Only when it's a difference of 2 squares you can take it one step further. Alright, so A, B, and E are okay, but then C and D, I need to talk about it. Let's talk about it. Okay, so how do we do this? Alright. Hopefully done. We're going to go down to C in a minute. So C is a little bit interesting, and because it doesn't look like we can use the technique we've discussed before, but we can do that. And there's some textbook question that has this question. Let's go down. All right, now there's no common factor. See this one, t to the power 4, there's a common, no problem. But this one I can't take out x squared because 4 doesn't have an x squared. But I could still factorize it. this is what you do. This is a little bit like a quadratic, but it's not a quadratic because it's not x squared, but it's like a quadratic. It has the same structure. So what you do is this. You can see that -3, -4, actually you can write it like this. You can write it like x squared. So it's like a quadratic, right? It's like a quadratic, except the thing being square is the x squared, right? So you pretend this is like a y. So because it's a quadratic looking like that, what you could do, so you just pretend this is like this question. It's like y squared minus 3y minus 4, except you have x squared instead of y. Yes? So that means you have to pick two numbers which multiply to get -4, add to get -3, which is -4 and 1, isn't it? So what you do is, in the bracket, you write x squared minus 4, x squared plus 1. Hopefully you can see that, because it's like a quadratic, but except this time it's an x squared, instead of just a single polynomial like a y. Right? So it's very similar. So just pretend you have an easier question. So this one becomes y minus 4y plus 1. But now the y is now replaced by the x squared. So you write x squared minus 4, x squared plus 1. Hopefully that makes sense. See, this one becomes y minus 4, y plus 1. So this one will be x squared minus 4, x squared plus 1. All right? Of course, yes. What do we do next, Dad? What should we do? Yes, well spotted. So every time you see difference of two square, you need to break it into two parts. Okay, that's good. Any question? Good. Hopefully, how about the next one? Okay, hopefully you can see that it's the same thing again. How can you write it? You can write the x to the power 6 as x cubed squared, right? Because by index law, you times the 3 by the 2, right? So if you square x cubed, you get the x to the power 6 minus 7x cubed minus a. So it's a quadratic. It's a quadratic in x cubed, right? You get the same structure. So when you do that, you just go x cubed, like this. And find two numbers which multiply to get -8, add to get -7, which is -8 plus 1. Is that our final answer? The answer is no. We just did difference of two cubes and sum of two cubes today. And this one, you have got everything. So you get to use everything we did today in one question. Let's do that. So can you see that's the difference of two cubes? So you can write that as x minus 2, x squared plus 2x plus 4, right? The first one, this is just the first one. And the second one is the sum of two cubes. So you get to do everything in one question. X plus 1, x squared minus x plus 1. Yeah, all of these things with three terms all of a sudden has got 4 factors. Very big. Yeah. Right, so they are a little bit challenging, but it does apply a lot of rules in one question, isn't it? That's why it's challenging. All right. And of course, you will expect some of the questions in your exam are like this. So make sure you study this, because they will be asked in the exam. Now, we've still got a few more to do. Let's look at the other one soon. I have to think of a way to explain f. Again, f is like a quadratic, but in a different way from c, right? Because there's two polynomial. Right, so that's the tricky bit. So what do I do? All right, let's do the f1. Again, there's no common factor, but it is still a quadratic. Now, how do I put it to you? Maybe if you use the cross method, it will be very easy. But if not, it's a quadratic. Okay, but maybe let's do it this way. Let's do it this way. All right. So you just go like this. It's going to be x and x, right? And the question is, what do I put in here? So what you do is this. Now, this is negative 3t squared. So you have to find two things that multiply to get negative 3t squared, in which case must be negative 3t and t, right? And they must add to get 2xt. Oh, okay. Alright, so maybe we'll just go 3t minus t. Yeah, because the 3 and negative 1 adds up to 2. So that should work. If I write 3t here, minus t here works. Let's see if it works, because if you expand these two, you get 3tx, and then these two will be minus xt. You do get 2xt, isn't it? Which is this term. Yeah, so it's a quadratic except that you have a polynomial instead of a number. Yeah? And the g is very horrible, so it's a non-monic one. So you could try that by yourself. You could try it. I will go through it as well. Just go through everything. Alright, hopefully you can understand F. So it's like this one. You put the xx, 3t minus t. Next one again, you do a little bit of experimentation. You go 2 brackets again. See the 5b squared? Just write 5b here, b there, because 5b times b is 5b squared. And then you look out for the negative 8. So the negative 8 is negative. Okay. Okay, how about do this? So you go 5 there, and you do a non-monic case like that. And then you do 5 times negative 8, which is equal to negative 40. So two numbers which multiply to get negative 40 add to get negative 3. Right? See, there's a negative 3 there. So what would it be? Plus to get negative 3 times to get negative 40. That's a little bit harder. Anyone got suggestion? One of them has to be negative. Perfect. Negative 8, positive 5. Done. Oh, not yet. See, there's a p there. Put a p, because there's a p. Right? And then if you factorize, we get 5b minus ap. And then take the 5 out, which is b plus p. Right? Over 5. And the 5 gets cancelled. So your final answer will be 5b minus 8p. Not working well. 5b minus ap. And then the other one, b plus p. Yeah. So it's like a non-monic, except that there's a p at the end. And you factorize the 5. Alright, have a try. And then we've got one more. Alright, the last one is very hard, but we'll still give it a try. But if you can work out, that's very amazing. Anyone worked out? Okay. Anyone? Give you maybe. So I just leave it on for, okay. Let's see. Okay. We have to be very strategic. Let's separate them into two parts. Let's look at this one first. We want to factorize. Now, if you look more carefully enough, that's actually a perfect square. I'm going to write x plus 2y all squared. Can you see that? If you expand that, I will get this. Perfect square, right? A squared, 2ab, get to 4xy, plus the 2y squared, we get 4y squared. Now, the second one, you have to do something special, taking out the negative. So it becomes a squared minus 2ab plus b squared. Anyone recognize the second one? Yeah, what's the second one? That's also a perfect square, right? A minus b all squared. Now, what do I do with this thing? What's that called now? This is a, what would that be? What should we call that? That is difference of two squares, but except it has more things in it, right? So we're going to do difference of two squares on that. It's going to be a massive difference of two squares. So it's like pretend there's a big A and a big B square, and you get A minus B, A plus B. Now remember, A is the x plus 2y. So let's prepare ourselves for battle. So we put this inside here. So the A, remember what A is the x plus 2y. Right? That's the A. Minus. The B is the A minus B. But remember, when you minus, make sure you put a little bracket like that. And the second one's easy because you just go x plus 2y plus A minus B, right? So the first one is the minus, the second one is the plus. And then you just have to do one more step of x plus 2y, take out the negative, so write negative A plus B. X plus 2y plus A minus B. Yeah. If you can do this question, you can do any question now. Alright, but study that very carefully. Okay? Well, you did very well today. We did some very challenging questions. That's, I think, as hard as you should get. Oh, sorry. I'll make it a bit bigger. There we go. Alright. Have fun. So do 2 exercises today. Please, thank you. Which is, let me just go to the front page very quickly. So the one you should be doing is, today is these two. The sum and difference of 2 cubes, which is 16th of February. So make sure you write the date. And then mixed factors. So you're doing exercise 2.14, 2.13. Right? Any question, ask me. Any question from homework, ask me. Alright, good. I leave it in here. And save. And we're done. So we just have to stop.